ever look at a Formula One car or a modern fighter jet and just wonder, how do they make something so incredibly strong but also unbelievably light? Well, the answer is a material that honestly sounds like it's from the future. It's called Prepreg carbon fiber, and we're about to break down exactly what makes it so special.
Just let that sink in for a second. 85% of the car's structure is made from this stuff, but it only makes up a fifth of its total weight. That is a mind-blowing strength-to-weight ratio. It just perfectly shows how revolutionary this technology really is.
Exactly. It almost feels like it's breaking the laws of physics, right? How can you have something that's super rigid and strong, but also light as a feather? Well, the secret isn't just about using carbon fiber, it's about using a very specific, very high-tech version of it.
See, the key to all this amazing performance is an advanced composite material. It gives engineers a level of control and precision that lets them build parts that not too long ago were pretty much impossible.
And this is it. The word is prepreg, and it's just short for pre-impregnated. Now, the key thing to get here is that the resin, the glue that holds all those carbon fibers together, isn't just slopped on by hand. Nope, it's applied with machine-like precision at a factory, which creates this perfectly balanced, ready-to-use sheet of material.
Now, to really get why this is such a game changer, you've got to compare it to the old school way of doing things, the wet layup method. And trust me, the difference is like night and day.
So on one side, you've got prepreg. It's clean, it's consistent, it's scientifically precise. And on the other side, you have the wet layup method. That means someone is literally painting liquid resin onto dry carbon fabric by hand. It can get messy, and the final quality really depends on who's doing it. It's basically a high-tech lab versus an arts and crafts project.
And the numbers, well, they tell the whole story. Look, prepreg costs more upfront, no doubt about it. But check out the quality. The fiber volume, that's the amount of actual carbon fiber doing the work, is way higher. And the void content, which are basically tiny air bubbles that make the part weaker, is way, way lower. This is why prepreg gives you that aerospace-grade performance every single time.
So how do they actually make this stuff? Let's pull back the curtain and take a look at the industrial process that turns raw fiber and sticky resin into these incredible sheets of high-performance material.
Okay, so the most common way to do this is called the hot melt process. It really boils down to two main stages. First, you have to create a flawless film of resin. And second, you have to get that resin perfectly infused into the carbon fibers.
All right, step one, that golden honey-like stuff you see, that's the epoxy resin. A machine is carefully coating it onto a release paper, making sure the film has a perfectly uniform thickness. We're talking down to the micron. It is all about absolute control.
At the exact same time, thousands of spools of raw carbon fiber are being fed into another machine. Every single bundle of fibers gets meticulously lined up and spread out under perfect tension. They're getting everything ready for the resin. There is absolutely no room for error here.
And here is where the magic happens. The resin film and those perfectly aligned carbon fibers are brought together under just the right amount of heat and pressure. The resin melts just enough to completely soak into the fibers, creating a single, uniform sheet of prepreg. Then it all gets rolled up and stored in a giant freezer to basically hit pause on the curing process until it's ready to be used.
So we've got this incredible, game-changing material that's pushing engineering to new heights. But all that success has created a huge and growing problem that we just can't ignore anymore.
This quote from Singapore's Agency for Science, Technology and Research, or ASTAR, really says it all. We have a serious environmental challenge on our hands.
I mean, think about it. What happens when a multi-million-dollar race car crashes or an airplane wing gets retired? The big issue is that those carbon fibers are locked inside that super strong epoxy resin. You can't just melt it down and reuse it like aluminum. For a long time, that meant most of this amazing, valuable material ended up in a landfill, just wasted.
But here's the cool part. Just like engineering created the material, it's also creating the solution. Scientists are now figuring out brilliant ways to close the loop on carbon fiber, giving it a second, third, even fourth life.
Researchers at ASTAR have developed this incredible process called Solvolysis. It's a really clever chemical reaction that basically dissolves the epoxy resin away, which frees up those valuable carbon fibers so they can be captured and reused, all without damaging them.
And this is why it's a total game changer. The whole thing is pretty simple, and it uses way less energy than making new carbon fiber from scratch, plus it uses greener chemicals and a closed-loop system so nothing is wasted.
But the really crucial part? It recovers the fibers while keeping their original woven structure intact, which is everything when it comes to performance.
Now get ready for the most amazing number of all. The reclaimed fibers keep over 90% of their original strength. That is just incredible. It means we can take waste from a retired airplane and use it to build high-performance parts for cars or boats or new sports gear. We're saving a massive amount of energy and resources. You know, it's just a perfect example of innovation solving the problems that it creates. First, we engineer an impossible material, and then we engineer an impossible solution to recycle it. It really makes you wonder, with manufacturing moving this fast, what's next?